is video number 3 of lesson 4.2. I just realized that I made a mistake here. This was supposed to be 208 degrees, not 308 degrees, which would give us 104 degrees. So I'm going to check and make sure that my 152 plus my 104 plus 104, because each of these angles would be 104. Let's make sure this adds up to my 360. So I get 10, carry the 1 is 6, and 360 degrees, which is what should be in a circle. So each of these angles is 104 degrees. So now I know that this angle is 104, and this angle is 104. So now I can find the length of the arc. Remember that in order to find the length of an arc, you take the fraction of the circle, we multiply it by the circumference, and that gives us the arc length. The fraction of the circle is 104 degrees out of 360 degrees times the circumference. Let's see, since the radius is 4, my circumference equals 2 pi r, which would be 2 pi times 4, since that radius is 4, and I get 8 pi for the circumference, so times 8 pi equals, and I'm going to go ahead and use my calculator. I know I'm going to have to keep pi in the answer, and I have 104 times 8, and I'm going to divide that by 360, and I get 2.31 pi. I can make sure that that fraction wouldn't be easier. Math, enter, enter. 104 over 45 pi. I'll just leave it as 2.31 pi. Alright, I'm supposed to find the length of major arc A, B, C. I'm going to highlight that. A, B, C, all the way around to there. And well, actually, we're told that the length of arc, ABC, is 16 pi. So we're now supposed to find the measure of arc AC. So the one that we're looking for is actually the one I'm going to highlight in green. We're looking for arc AC. All right. So we know that the measure of this arc here is going to be, again, the measure of the arc is, length of the arc, is, so we have fraction of the circle times circumference equals arc length. So I don't know what this fraction is. I'm going to find the angle for this, which will then give me the angle for this. So the fraction of the circle, I don't know what that is, so theta divided by 360 times the circumference. The circumference is 2 pi r, which is 2 times pi times 10, or 20 pi, equals the arc length, which is 16 pi. Right? So I'm going to multiply by 360 to get these 360s to cancel. I'm going to put that in the numerator and 20 pi in the denominator. Do the same thing on this side. And the 360s cancel and the 20 pi's cancel. And theta equals, and on this side the pi's cancel, and I get 16 times 360, and then I divide that by 20, and I get that theta is 288 degrees. So if this is 288 degrees, this angle right here must be 360 minus 288. And when I subtract that, I get 72 degrees. Therefore, this angle is 72 degrees. I can now find the length of the arc AC. So the length of the arc, again, is fraction of the circle. I'm going to use this formula again. Now I'm going to use 72 degrees divided by 360 times the circumference, and I know that my circumference is 20 pi, and that will give me my arc length. So 72 times 20 divided by 360 is 4. So I get 4 pi. That is the length of the arc. Now I'd like to talk about another way that we could have done this problem. We found this angle, which allowed us to find this angle, which allowed us to find this arc. However, there was another way we could have done it. We know that the entire circle, which is the circumference, is 2 times pi times 10, which is 20 pi. We know that the orange arc, or arc ABC, was 16 pi. If you subtract 16 pi, then the green part is left 4 pi. That is another way that we could have solved this problem. All right, let's look at number 7. The length of arc BA is 14 pi. So let's see, from B to A, and since it's listed with 2, it means it's the minor arc BA. So the orange, I'm going to label, is 14 pi. What is the measure of arc BC? Now, I do want to clarify that the 14 pi is all the way from A to B. It's not just this part here at the 76. It's just where I have it labeled. So this entire arc is 14 pi, which means we need to figure out what this entire angle is. So we're going to use our formula again, fraction of a circle times circumference equals arc length. So I don't know what my whole angle is. I know part of it's 76, but I don't know the whole angle. The circumference is 2 pi r, or 2 pi times 18, which would give me 36 pi. So times 36 pi equals my arc length, which is 14 pi. I'm going to multiply both sides by 360 over 36 pi, so that the 360s and the 36 pi's cancel. Same thing on the other side, 360 over 36 pi. The pi's cancel, and I'm left with theta equals 14 times 360, and then divided by 36. So theta is 140 degrees, which means this entire angle here is 140 degrees. And it asks for the measure. Measure just means the angle. That's a magnitude. That's not a length. We just want the measure. So we want this angle right here for BC. This is what we're looking for. This is our question mark, which is simply 140 degrees minus the 76. When I subtract, I get 64 degrees. For lesson master 4.2, it says find the length of an arc of a circle of a radius of 8 meters if the central angle of the arc is 5 pi over 6. So we know that we need the fraction of the circle, which is this central angle right here. They've already given us, so we want to do the fraction of the circle, which would be 5 pi over 6 divided by 2 pi, because we're not dividing by 360, because we're dealing with radians, times the circumference. Circumference is 2 pi r, which would be 2 times pi times 8, or 16 pi, times 16 pi. All right, let's see if we can straighten this out here. So we've got 5 pi over 6 times 1 over 2 pi. Remember, when you divide by 2 pi, you multiply by the reciprocal, and then times 16 pi. Well, we've got these pi's cancel, and since I can use a calculator, I'm going to have 5 times 16, and then divided by 12, because 6 times 2 is 12, and then times pi. And I get approximately 20.94. So again, these pi's canceled, 5 times 16 divided by 12, and then I multiplied by pi. Number 2, find the area of a sector. I've given you the formula for that. Fraction of the circle. The central angle is 315 degrees. So my fraction of my circle is 315 divided by 360 times area of the circle. If the diameter is 11, if the diameter is 22, the radius is 11. I was getting ahead of myself. And so the area of a circle is pi r squared, which would be pi times 11 squared, which is 121 pi. 121 pi. I'm going to go ahead and put all of that in my calculator. 315 times 121 times pi, and then divided by 360, and I get 332.62 inches squared. Number 3, the arc of a circle of radius 4 centimeters has a length of 2 pi over 3 centimeters. Find the measure of the central angle in both radians and in degrees. All right, so again, I'm using my formula where I say the fraction of my circle, and I don't know what the angle is, so I'm going to call it theta, divided by, let's just say divided by 2 pi rather than divided by 360, since we've got an arc length that's in radians, times the area of, the circumference of the circle. Circumference is 2 pi r, which is 2 times pi times 4, which is 8 pi, times 8 pi equals the arc length, which is 2 pi over 3. All right, so now what I'm going to do is I've got to get theta by itself. But right here, I already see that 8 pi over 2 pi is simply 4. So I can just divide both sides by 4, or multiply by 1/4, which gives me 2 pi over 12, which is pi over 6. That is my answer in radians. Because I chose to solve in radians, I convert that to degrees by multiplying by 180 over pi, and I will get 30 degrees.